Hello students and welcome to Unit 3. This unit is going to be focusing on expressions, and today in our first lesson we are going to receive an introduction to expressions. Our essential questions for today are: what are expressions in mathematics? What are some types of expressions that exist in our world, and there will be two types? And how can we write expressions that represent real-world problems? We'll be looking at real-world problems today and trying to assign one of the two types of expressions to them. As we start to think about expressions, I want you to connect it to something that you already know. Expressions in math are kind of like facial expressions. Facial expressions represent a feeling, and mathematical expressions represent an amount. So they're both a representation of something. So math expressions, what are they? A mathematical expression is a symbol or symbols used to represent a quantity. So anything that you can use to represent an amount is an expression. Remember, quantity and amount are synonyms for each other. Expressions are nothing new to you. You've been studying expressions for quite a long time. Even when you were in kindergarten, you received a worksheet that looked like this, and it said count how many, and you looked at the butterflies and you said there were 2, and you drew the number 2 in the box. You were writing an expression. That symbol that you drew, the way you draw a 2, the numeral, this is a symbol that represents the quantity of 2. So expressions are nothing new to you. It's just that you are going to be using them in new ways. Now, expressions have many parts. So if you think about the expression that we just wrote, the number 2, that is an example of a constant. A symbol that always represents the same amount. So for instance, if we're talking about the 2 butterflies, or my 2 kids, or your $2, or 2 cars in the parking lot, the number 2 always represents the same amount, no matter what situation it is represented by. Now, an expression can contain more than just a number. It could have an operation as well. And when you think about operations, you think about add, subtract, multiply, divide, squares or cubes, any exponents, square roots. These are all types of operations, absolute value symbols. All operations can be part of an expression. So for instance, instead of just saying 2, you might say 2 plus 5. I had $2 and I received 5 more. That's an operation that can be used to describe an amount that you have. Now, it can also contain grouping symbols. Grouping symbols are like parentheses or braces or brackets, square root symbols, absolute value symbols, fraction bars. These are all types of grouping symbols, and you can have those if you're trying to describe an amount. A square root describes an amount. And last, expressions can have variables. A variable is a symbol, usually a letter, that represents an unknown or a changing quantity. So for instance, when you go to the lunchroom and you buy milk, when the cashier puts it into her computer to charge you, the computer is set up as a variable because it doesn't necessarily know how many containers of milk someone is going to buy. Any time that a quantity can change or a quantity is unknown, a variable may exist. And we'll look at some examples of this in a couple minutes. Now, there are two categories of expressions, numeric expressions and algebraic expressions. If you look at the way they both begin, numeric almost looks like the word number, and algebraic almost looks like the word algebra or alphabet. These will help you to make connections to what each expression can contain. Now, here are some examples of some numeric expressions. If you notice, what do they contain? And if you look at the algebraic examples, you see similarities in what they contain, but you see one major difference. So if we go back to the numeric expressions, we can see that they contain no variables, whereas the algebraic expressions contain variables. Now they both do have constants, operation, and grouping symbols, but the major difference is algebraic expressions must have at least one variable. So as soon as you see a variable, you will know it's algebraic. If you do not see a variable, you will know that it is numeric. Now, both types of expressions can be simplified. Numeric expressions can be simplified using the order of operations. Algebraic expressions are simplified by combining like terms. Now, I'm not really concerned in this lesson that you can do these two skills, but I just want to set you up for some prior knowledge when we go to our next couple lessons. We will study the process of simplifying in our next lesson. Today's task is not to be able to simplify expressions, but to learn to write expressions to represent situations. So the main idea is, how do you know if the expression will be numeric or algebraic? Well, if it's algebraic, there will be at least one quantity in the situation that you do not know the value of. Remember, a variable is a symbol that stands for an amount you don't know. So in order to have a variable, you have to have an unknown value, and that's what makes it algebraic. Now, if you do determine that it's algebraic, you need to define your variables, which means to state what each variable stands for. So for instance, you may say that A equals Adelie's height. You do not know Adelie's height, so you're going to put the variable A anywhere that Adelie's height is going to be represented. That's an example of defining your variable, quickly stating what the variable stands for. So let's write an expression for an example. Here you see Adelie and Cohen. You could make a statement, something like this about the picture. Cohen is 5 inches shorter than Adelie. So if you wanted to describe Cohen's height, you might say that his height is Adelie's height, which we're going to represent by A, minus 5. Now remember, if it's algebraic, we have to define what A means. So A stands for Adelie's height. Now, this is an example of an algebraic example because we had an unknown value. We know that Cohen is 5 inches shorter than Adelie, but we do not know how tall that is because we do not know Adelie's height. And that's why this is algebraic. That's why it has an unknown value. Now, with one slight difference to the statement can become numeric. Cohen is 5 inches shorter than Adelie, who is 36 inches tall. Well, now you know that Adelie's height is 36, so 36 minus 5 is how tall Cohen is, or 31. Notice, here we can know exactly how tall Cohen is, but here we cannot because there was an unknown value that we were relying on. The first example is an example of an algebraic expression, and the second is an example of a numeric expression. Let's look at another example. Remember, think about whether you know or do not know something in the statement. Kara had $7. She earned more money by babysitting for 3 hours, where she earned $8.50 per, now remember we know what per means multiply, hour. Now, we don't know how much money she earned in all, but we could write a numeric expression to figure that out. She had $7. She earned more, which means to add more money, by babysitting for 3 hours. 3 hours is going to go here, where she earned $8.50 per, which means multiply hour, which is 3. Now, order of operations says we would have to multiply first, but if you wanted to, you could put parentheses around here. You wouldn't have to. Okay? There's an example of a numeric expression. Let's look at another example. Jordan is saving money towards a new Xbox. He currently has $75 saved. He also saves an additional $15 per, which means per, multiply, week. Well, we don't know how many weeks he's been saving. So let's let W equal number of weeks he has saved. Now, we can write an algebraic expression to show how much money he currently has. Well, he has $75 saved, plus he is saving an additional $15 per, which means multiply, week. And we do not have to put a multiplication sign. If a constant and a variable are touching each other, it's assumed it's multiplication. So here is our expression that represents the amount of money Jordan earned. Because you are sick, your brother agrees to give you 1/3 of, we know that of means to multiply, 1/3 of his Halloween candy from trick-or-treating. Well, we don't know how much Halloween candy he's going to get, so let's let H be the number of pieces of Halloween candy. So we know that your brother is going to give you 1/3 of his Halloween candy. So whatever he gets, you're going to get 1/3 of, which means to multiply by the number of pieces that he has. Or you could write it without the multiplication sign, 1/3 each. Either of them is a good way of representing that situation algebraically. A fitness club charges $1.75 per day of membership. If you are a member from July 1st through August 20th, how much do you owe? Well, if you think about this, it says $1.75 per, which means to multiply by the number of days. Do we know the number of days that you are a member? Yes. We know that there are 31 days in July plus the 20 days in August that you were part of the membership club, and we will have to multiply the number of days by $1.75. Now you could have that reverse, $1.75 times 31 plus 20, but you do need the 31 plus 20 in parentheses, because if not, multiplication would come before that addition, and you need to add to figure out the total number of days first. This is how you could represent the amount of money that you owe numerically.